Have you ever imagined living above Earth, watching it spin endlessly below? A place where sunrise repeats 16 times every single day without stopping. That idea once sounded impossible, even foolish to most scientists on Earth. Yet humanity kept asking one question that refused to disappear from minds. What would it take to build a permanent home beyond our planet's atmosphere? That question eventually led to the creation of the International Space Station. But before it existed, space was a battlefield of pride and competition. Nations raced to the stars, trying to prove technological superiority over others. The sky became a silent arena where politics played out beyond Earth. Every rocket launch carried not just science, but national identity and ambition. For years, cooperation in space seemed impossible between rival global superpowers. However, scientists quietly dreamed of something very different from competition and division. They imagined a place where humanity could work together instead of apart, a floating laboratory where knowledge mattered more than flags or borders below. Slowly, this idea began spreading among engineers, astronauts, and political leaders worldwide. It started as a whisper, almost too bold to be taken seriously initially. But science has a way of turning impossible dreams into future realities. The Cold War tensions began easing, opening doors to unexpected collaboration opportunities. Former rivals started realizing that space was too large for any single nation. Building something in orbit required shared resources, trust, and long-term commitment. This realization slowly transformed competition into cooperation across multiple space agencies globally. The United States and Russia began discussing potential joint projects in space. Europe, Japan, and Canada also joined early conversations about orbital collaboration efforts. What once seemed like science fiction was becoming structured engineering planning sessions. Each nation brought unique expertise, technology, and ambition into shared discussions. Engineers envisioned modular structures that could be launched separately and assembled in orbit. This approach made the impossible idea suddenly feel technically achievable and realistic. But trust was still fragile between nations, with decades of historical tension. Every agreement required careful negotiation, precision, and long-term strategic planning commitments. Despite challenges, momentum continued building towards something unprecedented in human history. The dream of a permanent orbital station was no longer just imagination. It was slowly becoming a structured international mission with real political backing. Scientists worked tirelessly to design systems that could support human life in space. Life support, energy systems, and docking mechanisms all needed flawless engineering solutions. Every detail mattered because failure in space would mean irreversible consequences instantly. The stakes were incredibly high, but so was the potential for discovery. A shared vision was finally emerging among nations that once stood divided. They agreed to build something that would orbit Earth for decades, continuously, a structure that would symbolize peace, science, and unity beyond national boundaries. This agreement marked the beginning of one of humanity's greatest engineering collaborations. The foundation of the space station project was finally set into motion. What followed would change how humanity sees itself in the universe forever. But the journey from idea to reality was only just beginning at that moment, and soon, humanity would start assembling its first true home in space. The dream of an orbital home slowly turned into real engineering plans worldwide. Space agencies began meeting regularly to design a station that could actually work. Every meeting carried the weight of history, politics, and scientific ambition combined. The idea was no longer fantasy, but a serious international engineering project. The United States took a leading role in early structural planning and coordination. Russia contributed decades of experience from long-duration space station operations in orbit. Europe brought advanced laboratory modules and precision engineering systems for scientific research. Japan added cutting-edge technology for experiments and robotic assembly in microgravity environments. Canada contributed the famous robotic arm that would later assemble the station components. Each nation became essential, like pieces of a puzzle too large for one. This cooperation marked a turning point in space history never seen before globally. For the first time, former rivals worked toward a shared orbital structure. The International Space Station became a symbol of unity in space exploration. But building it required solving problems humanity had never faced before in orbit. How do you assemble massive structures while floating hundreds of kilometers above Earth? Engineers had to design everything to survive launch, vacuum, and zero-gravity conditions. Every bolt, panel, and module needed extreme precision beyond typical Earth construction standards. Even the smallest miscalculation could lead to catastrophic failure in space instantly. Launch vehicles were carefully selected for transporting fragile components safely into orbit. Each module was launched separately from different countries across multiple years of planning. Once in orbit, astronauts would connect them like floating pieces of advanced machinery. Training for this process took years of simulations on Earth and underwater environments. Astronauts practiced spacewalks in giant pools to mimic weightlessness before actual missions. These preparations were essential because mistakes in space could not be easily fixed. The first module launches marked the beginning of physical construction in orbit. Each successful docking brought excitement, relief, and renewed international collaboration efforts. The station began to take shape slowly, orbiting Earth every 90 minutes. Watching it grow piece by piece was like assembling humanity's shared future. Engineers on Earth monitored every movement with extreme precision and constant communication. The complexity of coordination required flawless synchronization between multiple space agencies worldwide. Despite language barriers, technology allowed seamless communication between international mission control centers. The station became a floating construction site, unlike anything built in human history. Astronauts became construction workers, operating in one of the most hostile environments possible. Every spacewalk involved danger, exhaustion, and absolute focus on mission success. Yet every completed task brought humanity closer to its first permanent space home. As modules connected, the structure began resembling a real living laboratory in orbit. Power systems, oxygen circulation, and communication networks had to function perfectly together. Life support systems were tested repeatedly to ensure astronaut survival in space. Scientific equipment was installed gradually as more modules joined the growing station. Each addition expanded research capabilities beyond anything previously possible in space. The station was no longer just an idea, but a functioning orbital structure. It represented years of negotiation, engineering, and international cooperation finally realized above Earth. Every nation involved shared pride in seeing their contribution floating in space. But the most challenging phase of construction was still ahead in orbit, because building something so complex in microgravity was far from complete. And soon humans would begin living inside this extraordinary structure permanently. The journey from construction to habitation was about to begin in orbit, and life in space would test humanity in ways never imagined before. But the station was finally ready to become more than metal in space. The moment humans first entered the station changed everything about space exploration. After years of construction, the structure was finally ready for permanent habitation. Astronauts floated through newly connected modules, entering humanity's first orbital home. The silence inside the station felt different from anything experienced on Earth. Every movement was slow, graceful, and completely free from gravity's pull. The International Space Station was no longer construction, it was now living space. For the first time, humans would sleep, eat, and work permanently in orbit. The transition from construction site to home was both emotional and historic. Astronauts described the feeling as stepping into the future of humanity itself. Every wall, panel, and system now supported real human life above Earth. The station orbited Earth every 90 minutes, creating endless sunrises and sunsets. Time itself felt strange, as day and night no longer followed normal patterns. Sleeping required special restraints, since astronauts floated freely without gravity's grounding force. Even simple tasks like drinking water became complex and fascinating experiments in space. Water floated in spheres, reflecting light like tiny drifting planets inside modules. Food had to be specially prepared to prevent crumbs from floating everywhere. Every daily routine required adaptation to a completely new physical environment. But humans adapted quickly, driven by curiosity and determination to survive in orbit. Scientific experiments began almost immediately after the first crew settled inside. Researchers studied how the human body reacts to long-term space exposure. Muscles weakened, bones changed, and adaptation became a key scientific focus. Every observation helped improve future long-duration space missions beyond Earth. The station became a living laboratory, unlike anything ever built before. Experiments in microgravity revealed behaviors of fluids, fire, and materials differently. Even flames behaved strangely, forming perfect blue spheres instead of upward shapes. Earth observation became another powerful function of the orbiting station. Astronauts could see hurricanes forming, forests changing, and cities glowing at night. From space, Earth appeared fragile, beautiful, and incredibly thin in atmosphere. That perspective deeply affected every astronaut who lived aboard the station. They often described Earth as a shared home without visible borders. International collaboration inside the station reflected that same global unity concept. Crews from different countries worked together seamlessly in confined orbital spaces. Language barriers faded as teamwork became essential for survival and success. Every astronaut trained for years to handle emergencies in microgravity conditions. Yet even training could not fully prepare them for real space life. Technical maintenance was constant, since space environment slowly damages all materials. Solar panels powered the station, capturing energy from sunlight in orbit. Communication with Earth was maintained through advanced satellite systems continuously. Mission control centers on Earth monitored every system second by second. Despite distance, astronauts never truly felt disconnected from humanity below. They often looked down at Earth, feeling both distance and deep connection. Spacewalks became routine, but always remained dangerous and physically demanding tasks. Outside the station, astronauts floated in complete silence above Earth's surface. One small mistake could be life-threatening in the vacuum of space. Yet they continued, repairing, upgrading, and expanding the station's capabilities. The station slowly became more advanced, supporting longer and more complex missions. It transformed from experiment into permanent symbol of human presence in orbit. Each new crew brought new knowledge, experiments, and cultural exchange into space. The station became not just scientific but deeply human in experience. It proved humans could live beyond Earth for extended periods successfully. And with every passing day, humanity's confidence in space exploration grew stronger. But beyond science, something deeper was happening to human perception itself. Because seeing Earth from orbit changes how you understand life completely, and soon that perspective would reshape humanity's future beyond imagination. The station had become more than a structure, it became a mirror of Earth, and what it reflected would change humanity forever in ways no one expected. Life aboard the station evolved from survival into continuous scientific exploration. The orbiting laboratory became humanity's most advanced research facility above Earth. Inside the International Space Station, experiments ran every hour without pause. Scientists on Earth depended on astronauts to conduct precise microgravity research daily. Each experiment revealed behaviors impossible to observe under Earth's gravity conditions. Fluids behaved strangely, forming floating spheres instead of settling in containers normally. Fire burned in spherical shapes, challenging everything known about combustion science. Medical research became one of the station's most important scientific missions. Astronauts' bodies changed rapidly in microgravity, revealing long-term space health effects. Muscles weakened despite strict exercise routines performed for hours every day. Bones lost density, forcing scientists to rethink long-duration space travel completely. These discoveries became essential for future missions to the Moon and Mars. Every result helped engineers design safer spacecraft and better life support systems. The station also became a unique laboratory for studying human psychology in isolation. Astronauts lived in confined spaces for months, sometimes years, away from Earth. This isolation revealed how humans adapt emotionally to extreme environments in space. Despite challenges, crew members developed strong bonds and teamwork across cultures. International collaboration became visible in every shared task aboard the station. Scientists from different countries worked together seamlessly, despite political differences on Earth. The station proved that science could unite humanity beyond borders and conflicts. Earth observation studies expanded dramatically using high-resolution cameras from orbit. Astronauts tracked climate change, deforestation, and ocean patterns from above constantly. This data helped scientists understand Earth's changing environment more accurately than before. The station became a critical tool in studying natural disasters in real time. Hurricanes, wildfires, and storms were monitored as they developed across continents. This allowed faster response times and better disaster prediction models worldwide. Technology tested in space often found applications in everyday life on Earth. Water purification systems, medical devices, and materials improved through space research. Every experiment aboard the station contributed indirectly to human life improvement. The station also became a platform for testing spacecraft systems for deep space. Engineers studied how equipment performs in long-term exposure to space conditions. Robotic arms assisted astronauts in complex construction and maintenance operations outside. Spacewalks remained dangerous, requiring precision, training, and complete focus every time. Astronauts described floating in space as both terrifying and deeply peaceful simultaneously. Looking at Earth during spacewalks created powerful emotional and philosophical reflections. Many astronauts said they realized how fragile and connected humanity truly is. The station became a symbol of scientific curiosity and shared human destiny. Every passing year expanded its capabilities and scientific importance in orbit. New modules continued arriving, increasing research space and technological advancement on board. Communication systems improved, allowing faster data exchange with Earth-based research teams. The station became a bridge between Earth-bound science and space-based discovery. It allowed humanity to experiment beyond the limits of planetary constraints. Each discovery pushed the boundaries of what humans believed was possible. Astronauts became ambassadors of science, representing all nations in orbit together. Their daily lives demonstrated cooperation in one of the harshest environments imaginable. Even small repairs required teamwork, trust, and precise coordination between crew members. The station functioned like a floating city of science above Earth. And yet, despite its success, it constantly reminded humanity of its fragility. Because even in space, survival depends on systems working perfectly every second, and failure is never an option when Earth is far below. The station's existence proved both human brilliance and vulnerability in equal measure. But beyond science and survival, something even greater was being built. A vision of humanity's future beyond Earth was slowly taking shape in orbit. And that future would lead to even bigger dreams across the solar system. The station was no longer just an experiment, it was a foundation. And from that foundation, humanity began imagining worlds beyond its own. But the greatest chapter of its story was still yet to come. The station continued circling Earth like a silent guardian above humanity. Years turned into decades as the orbiting laboratory kept expanding its mission. The International Space Station became humanity's longest-running presence in space. What began as an experiment evolved into a symbol of global unity. Nations that once competed now shared responsibility for life above Earth. Every module told a story of cooperation, engineering, and shared ambition. Astronauts from around the world lived together in harmony in orbit. They worked, ate, and slept, while Earth quietly turned beneath them. The station proved that borders disappear when viewed from space above. It became a reminder that humanity shares one fragile planet together. Scientists continued discovering breakthroughs that reshaped medicine, physics, and biology research. Each experiment added another layer of understanding about life beyond gravity. Technologies tested in orbit began transforming industries back on Earth rapidly. Every advancement proved that space exploration benefits life on Earth directly. The station also inspired millions of young people to pursue science careers. Children looked up at night, knowing humans were living above them. This inspiration fueled a new generation of engineers, astronauts, and dreamers. The station became more than steel and modules floating in orbit. It became a story of human determination and collective imagination combined. Maintenance missions ensured the station remained operational despite harsh space conditions. Space debris and radiation constantly challenged its structure and safety systems. Yet engineers on Earth and astronauts in orbit overcame every obstacle. International teamwork kept the station alive through decades of continuous operation. Every repair performed in space extended humanity's reach a little further. The station also served as a testbed for future deep space missions. Lessons learned there prepared humanity for journeys to the Moon and Mars. Life support systems developed aboard the station became models for future spacecraft. Robotics technology advanced significantly through continuous orbital experimentation and upgrades. Communication systems evolved, making Earth-to-space interaction faster and more reliable. The station demonstrated that long-term human life in space is possible, but it also revealed the physical and emotional challenges of isolation. Astronauts experienced homesickness while floating hundreds of kilometers above their planet. Still, many described space as the most meaningful experience of their lives. Looking at Earth from orbit changed how they understood existence itself. They saw storms, cities, and continents without political divisions visible anywhere. That perspective deeply influenced global conversations about unity and responsibility. The station became a diplomatic symbol, floating silently above Earth's conflicts. It showed that collaboration is stronger than competition in the long term. Even after decades, new modules and missions continued extending its legacy. Private companies and new nations joined the era of orbital exploration. Space became more accessible, opening opportunities beyond government space agencies alone. The station paved the way for commercial space stations in future decades. Its success inspired ambitious plans for lunar bases and Mars missions. Humanity began shifting from Earth-bound thinking to interplanetary possibilities slowly. The station's presence proved that humans are no longer limited to Earth. It stands as evidence that we can live beyond our home planet. Every orbit it completes writes another chapter in human history silently. It continues circling Earth, unaffected by time below its trajectory path. And even as new spacecraft emerge, its legacy remains unmatched in orbit. It is not just a machine, but a milestone of civilization, a floating reminder that unity can build what once seemed impossible. One day it may retire, but its impact will never fade. Future explorers will look back at it as humanity's first home in space. It will always be remembered as the bridge between Earth and stars. And above us right now, it still silently watches our world, a symbol of what humanity becomes when it works together as one. A dream that left Earth and never stopped inspiring what comes next.